Now that we've described the structure, functionality, and key methods in the Java Phaser class, let's take a look at how to program the Java Phaser in practice. This program is based on examples in the Java documentation available at the Oracle website. I've added considerable comments, however, to go into a step-by-step analysis of what the various examples are doing. Let's first start by taking a look at the test driver program, which you can download at my GitHub repository at the link at the bottom of this slide. The main method is the entry point into the test program. It starts by creating a list of myTask objects. The details of what myTask does are not important for our discussion, although you could imagine that they would do things like the GCD algorithms that we talked about in the previous examples for cyclic barrier and countdown latch. We then go ahead and create a stream of ints from 1 to S number of tasks, and let's assume for sake of argument that that might be, could be 100, or it could be 4, or it could be 10, whatever the number is, some number that's defined as a constant. We then go ahead and take each of those numbers and create a new myTask object using the myTask constructor reference that's passed to the map-to-obj intermediate operation. Finally, we collect the stream of newly created myTasks objects into a list of myTasks using the collect terminal operation. Now that we've got the list of tasks we want to run, we're going to call two methods. First, we're going to call the runTasks method, which runs the test that showcases a OneShot phaser that runs a group of tasks that all start at the same time. So this basically works as an entry barrier. Next, we'll go ahead and run the test called startTask that showcases a cyclic phaser that repeatedly performs actions for a given number of iterations. This example illustrates the use of a phaser as a cyclic barrier. Let's start by taking a look at the OneShot phaser with Java. This OneShot phaser starts running a group of tasks simultaneously. In other words, they all start to run at the same time. The first thing we do is we go ahead and create a new phaser object with its parties parameter set to 1, thereby implicitly registering itself with the phaser. We then iterate through the list of tasks that were passed in as the parameter to the runTasks methods. And for each task, we inform the phaser there's a new party to add. So for every task, the count will go up by 1, the parties count will go up by 1. We then go ahead and create and start a new worker thread. This thread will run the task, but only after all the other threads arrive. The lambda expression inside of the thread constructor will use the phaser arrive and await advance method to block until all the other worker threads have started and called arrive and wait advance. So this is basically being used as a barrier. Next, we go ahead and run the task, whatever it might be, and this task will then run once, and all those threads will run, and all the tasks will run once. You'll notice that the main thread, the thread that called runTasks, will call the phaser arrive and deregister method. And this allows the thread that called the runTask method to continue, and it'll also cause this particular method or party to deregister itself so that the worker threads can all start running their tasks in the background. Let's now take a look at applying a cyclic phaser with Java. This cyclic phaser will repeatedly perform actions for a given number of iterations, which, as you can see, are passed in to the startTasks method along with a list of tasks we want to run for those iterations. Once again, you can download this example in my GitHub repository. We start by making a new phaser that will iterate for a given number of times. It does this by defining the onAdvance hook method, which we'll see is used to determine when the phaser should terminate. And the phaser will terminate when all the iterations have completed, when the phase number, which will be incremented every time all the phaser advances, when that finally reaches the iteration parameter that was passed into the startTasks method. As before, what we're going to do is we're going to arrange to register the calling thread, thereby deferring the worker threads, which we'll create in a second, from advancing to the second and subsequent phases until the end of this method. We then go ahead and iterate through all the tasks, For each task, we go ahead and inform the phaser there's a new party to add, and then we create a new thread. Now, when this thread is created, you can see it runs a do-while loop. And this do-while loop will immediately call task run to run the task for the first iteration for the phase. So after that runs, then it calls phaser arrive and await advance. And that is the barrier synchronizer that will block until all the other tasks and threads complete this phase. Note that the last thread to arise at the end of a given phase will trigger the invocation of the onAdvance hook method. And what that does is that checks to see whether or not the phase number has advanced to be equal to the iteration parameter that was passed in to the parameter as the parameter list to start tasks. Finally, the conditional portion of the do-while loop will check to see if the phaser has been terminated. If it has been terminated by the previous call to onAdvance, it'll go ahead and shut itself down and that loop will exit. Finally, you can see here that the phaser arrive and deregister method is called to deregister the calling thread, thereby allowing the task to advance to the second and subsequent phases. And we also don't want to block or wait, so this will return back to the main calling thread. So that's the end of our example application illustrating the use of Java phaser for a couple of different use cases.